Hi everyone, this is Life Changers Tutorials. I would like to encourage you that after going through the video, you can please click on the subscribe button and share and like the video. Okay, in this very video, we are going to be looking at Coulomb's law. And we can see that Coulomb's law states that the force of attraction or repulsion between two charges is directly proportional to the product of the charges, but inversely proportional to the square of the distance between them. Okay, according to that definition, Coulomb's law is equal to K, which is a constant, the proportionality constant, Q1, Q2, which is the magnitude of the two charges, all over R squared, which is the distance between them, the square of the distance between them, which we can also write as Q1, Q2 over 4 pi epsilon naught R squared. Now you should note that your K is the same thing as 1 over 4 pi epsilon naught, which is a constant value of 9 times 10 to the power 9 Newton meter squared per Coulomb square. It has a constant value. Okay, so now, but this particular formula is when the two charges are in a vacuum, when there is air or space between them. Now, we can also say that the force of attraction or repulsion is equal to Q1, Q2 over 4 pi epsilon naught epsilon R squared. If you notice, there's something added here. Now, this epsilon R here is called relative permittivity of the medium. If these two charges are in a medium that is not vacuum, the medium can be oil, the medium can be water. In that case, if you are dealing with a medium, then the relative permittivity has to be put in consideration. Where your 1 over 4 pi epsilon naught is represented with K, is now going to be K Q1 Q2 over epsilon R squared. Or you can just say that the force in this case is going to be the force when there is the force in a vacuum divided by the permittivity constant. That's another way you can represent this. Okay, now there is a theorem called Superposition Theorem in Coulomb's law. In this case, now there are multiple charges. The force of attraction between multiple charges on the force of attraction or repulsion between multiple charges on a particular charge. Now, he is saying that the resultant force is an algebraic form, an algebraic sum of all the forces acting on that body, the central body. Okay, so according to superposition theorem, your F is Q over 4 pi epsilon naught, which of course you can write as KQ, Q1 over R1 squared plus Q2 over R2 squared, and so on, depending on the number of charges. Which the whole of this now can be summarized as this. Your K is 1 over 4 pi epsilon naught, and that's your Q. Then the whole of this can be represented as summation of Qi over Ri squared. We are going to be seeing examples as we go. Okay? Now, we want to look at certain examples. The first one here, we ask to find the force of repulsion between charges 2 microcoulomb and 9 microcoulomb. Don't forget that like charges repel, unlike charges attract, if the distance between them is 3 centimeters. Now there's which is find the force of repulsion if both charges are in a medium, and we are given the permittivity constant here. Okay, so our force, remember our formula F equal to K Q1 Q2 over R squared. So my K here is 9 times 10 to the power 9, and my Q1 is 2 times 10 to the power minus 6. That's the first charge. The second charge is 9 times 10 to the power minus 6. Okay, minus 6. Why minus 6? That's microcoulomb. Micro means 10 to the power minus 6. Okay, now divided by the distance between the charges R is 3 centimeters. 3 centimeters when divided by 100 is giving us 0.03 meters. So we are going to have 0.03 squared. Now, if we use our calculator, the whole of this is going to give us 180 newtons. Okay. Now, that now leads us since they're in a medium, we can say that the force of repulsion in the medium is equal to the force of repulsion in a vacuum divided by the permittivity constant. I've given you that already. And that is going to be 180 newtons divided by the relative permittivity of the medium is 2.0. Okay, and that is going to give us 90 newtons. Now, we continue with other examples here. Here, we are given that equal charges are separated by a distance of 2 centimeters. If the force of repulsion between them is 120 newtons, find the magnitude of the charge. Okay, we are given that the force of repulsion between the two charges is 120 newtons. And we are given that the distance, the separation between them is 2 centimeters. 2 centimeters here is also 0.02 meters. That's when you divide by 100. So if we continue with our formula, we are going to have K Q1 Q2 all over R squared. But the question says that the two charges are equal, so we can as well write this as KQ squared all over R squared. So since we are looking for a charge Q, we can make Q the subject of formula. And if we do that, okay, we can start by saying F R squared all over K is, by cross multiplication, is equal to Q squared. Okay, so that means our Q now is square root of FR squared all over K. Now, which is equal to, if we substitute values, that is going to give us square root of my force is 120. R squared, that means 0.02 squared, that's the distance squared, all over K, which is a constant, 9 times 10 to the power 9. And when you use your calculator to calculate that, you're going to get 2.3 times 10 to the power minus 6 Coulomb, which is the same thing as 2 microcoulomb. 2.3 microcoulomb, sorry. Okay? That leads us to another example. Find the relationship between the gravitational force and the electric force between electron and proton in a hydrogen atom. Okay, electron and proton, there is a gravitational force between them. What is the formula for the force of gravity? Force of gravity is simply Gm1 m2 all over r squared. Okay, and the electrostatic force is, according to Coulomb's law, is kq1 q2 all over r squared. Okay, and whenever you're asked to find relationship, just simply go for the ratio, find the ratio. So we can say here that Fg over Fe is equal to Gm1 m2 all over r squared divided by kq1 q2 all over r squared. Okay, so this is now going to be equal to Gm1 m2 all over r squared times multiplied by your division now has this r squared over k q1 q2. Okay, good. So you see here that r squared can cancel out r squared. No wonder there's no need for distance. It's Gm1 m2 all over k q1 q2. Now some values are not given, even though we expected to know the values. Your G here stands for gravitational constant, which has a value of 6.6, about 6.6 times 10 to the power minus 11. Okay, multiplied by M1 can be the mass of a proton. Mass of a proton has a constant value of 9.1 times 10 to the power minus 20. Sorry, mass of an electron 9.1 times 10 to the power minus 31 times mass of proton is 1.6 times 10 to the power minus 27. Remember that these are constants. You're expected to know them. Now divided by your K is the electrical constant, which is 9 times 10 to the power 9 times. Your Q1 is the charge of electron. The charge of electron and the charge of a proton are the same, just that one is negative of the other. So 1.6 times 10 to the power minus 19 times 1.6 times 10 to the power minus 19. Remember that when you're dealing with Coulomb's law, you don't write the sign of the charges. The sign of the charges only helps us tell us the direction, if it's an attraction or repulsion. So when we calculate this using our calculator, we are going to get 4.17 times 10 to the power minus 40. So that is it. So the relationship between Fg and Fe is 4.17 times 10 to the power minus 4.